All right, starting lesson 6.5, proving triangles are similar using 3 shortcuts. All right, in the previous lesson, we learned that 2 figures are similar if the ratio of corresponding sides are equal and the corresponding angles are congruent. All right, now in this lesson, we will learn 3 shortcuts. These come in very handy for proving 2 triangles are similar. All right, first shortcut, we have AA. All right, now AA refers to the angles. So I have one pair of angles congruent, and I have a second pair of angles congruent. And if that's the case, the triangles are similar. Also, there's SSS, all right? But this is very different from the SSS when we're talking about triangles being congruent. All right, the SSS for similarity means that the ratio of the corresponding sides are equal. So here I have AB to DE. That's equal to BC over EF, which is equal to AC over DF. If that's the case, if you have this situation, and it's true, the triangles are similar right away. Then you know all the angles are congruent. All right, and the last one, SAS. All right, well here I have these angles are congruent, and then I have the corresponding sides that touch those angles, their ratio, and that's equal to the other ratio from the corresponding sides that touch that angle. All right, so then you have SAS, and once again, the triangles are similar. All right, just want to reiterate the point that the S has a different meaning with similarity than it does for congruence. All right, with congruence, the S is meant that the corresponding sides are congruent, or that they're equal. But with similarity, the S's mean that the ratios of the corresponding sides are equal. Okay, watch out for that. All right, so let's go over some examples and see how we can apply these shortcuts. If I could move down here, here we go. Okay. So it says, determine whether the triangles can be proved similar. If they are, provide a reason by stating the shortcut. Otherwise, state why the triangles are not similar. Okay, important. Depending on how you approach the problem, sometimes a different shortcut can be used. All right, so we're looking at part A here, and I have these angles are congruent, but then for one I have 30, for the other I have 60. Well, I know that all 3 of these angles add up to 180. So this angle is going to be 60. All right, which means that these angles here are congruent. So I have 2 pairs of congruent angles, which means I could say the triangles are similar by what shortcut? AA. Okay. Done with that. All right, and for the next one, let's see here. I'm going to go with the shortest side for the small triangle, and then go with the shortest side for the larger triangle. What does that reduce to? 2/3. Then I'm going to go with the medium side for the smaller triangle, and the medium side for the bigger triangle. 6/9. What does that reduce to? 2/3. And then I have the largest side for the smaller triangle, and the largest side for the bigger triangle. 8/12. That reduces to 2/3. All right, since all of the ratios are equal, all right, then I can say that the triangles are similar. So yes, by what shortcut? SSS. All right, let's do some more examples. For the next one, let's see, I have vertical angles here. All right, now let's come up with a ratio. All right, you have to be careful with which sides you select. All right, between these two, which one's smaller? The 25. Between these two, which one's smaller? The 20. Okay, this reduces to 5/4. Okay, let's look at the 35 now. I'm going to put that over 28. What does this reduce to? 5/4 as well. All right, since these ratios are equal, and these are the ratios constructed using the sides that make up the angles that are congruent, I could say the triangles are congruent by SAS. Done. All right, for part D, let's see what we have here. I have two triangles. I know that these angles are congruent. That's one pair. All right, well, this is 20 here, so that makes the other angle 70 degrees because they all have to add up to 180. But right away, there's no angle for this triangle that's 60 degrees. So I know right away that no, the triangles are not similar because there are not two pairs of congruent angles. All right, let's do some more examples. All right, it may get a little confusing at first, but let's break this down. All right, I have these two triangles here. I have this small one, and then I have this bigger one. All right, we're really going to have to work on analyzing these diagrams now. And they both share this one angle in common. It belongs to both of them. Okay, so what else do I have to work with? I have this side here for the blue triangle, which is 12. All right, I'm going to put that over this side of the bigger triangle, which is 18. That reduces to 2/3. Then I have this here. This is 14 for the blue triangle. Then this is 21 for the bigger triangle, and that reduces to 2/3. All right, since the ratios are equal, then I know that the triangles are similar by what shortcut? SAS. Done. All right, for part F, let's see once again. I have this small triangle here, and I have this big triangle here, and they both share this angle here in common, R. Okay, now let's set up some ratios. I have this side to the small triangle over this side for the big triangle, which is 20. And that reduces to what? 6/10 or 3/5. All right, and then I have this side for the small triangle, which corresponds to this side for the bigger triangle. That's 15. And that reduces to what? 3/5. All right, so I could say that these triangles are similar by SAS. Done. All right, for the next one, G, let's see what we have here. All right, I know that I have this red triangle here, and I have this blue triangle here. They both share one angle in common. All right, but they also share this angle right here. Together, they have the same angle. So these triangles right away are similar by AA. Done. All right, for part H, let's see. I have two parallel lines here. The arrowheads, very important whenever you see arrowheads. Okay, so I have two parallel lines. Here's one transversal. These are corresponding angles. Here's another transversal. These are corresponding angles. So these two triangles here, I have the small one and I have the big one. They are similar by AA. Done. All right, two more examples. All right, I have isosceles triangles here. So these angles are the same. Those are 71 degrees. All right, now if these two add up to 71, that's 142 If I subtract that from 180, I get 38, which makes this angle 38. Okay. All right, so look at what I have here now. I have two triangles. They both have a 38-degree angle. Okay. And now there's a bunch of different ways to approach this problem. You could show that these angles here are 71 degrees, and then you could say the triangles are similar by AA. I'm going to do this. I'm going to call these X and these Y. All right, because I don't know what their lengths are. But I'm going to take this side over this side, X over Y. And then I'm going to take this side over this side, X over Y. So the ratio of the sides that make up the angle, they're equal. So I could say yes by SAS, or you could just as well say yes by AA. All right, it's your choice, depending on how you work out the problem. All right, for J, let's see what we have here. All right, I have these two triangles. Okay, I know they have this angle in common. All right, there's a bunch of different things you could do here. Or maybe there's just one. We have this angle in common. Let's work with that. I'm going to call this X, and this Y, and this Y. All right, so this length here is 2X, and this length here is 2Y. Okay. So now if I take the ratio of the sides that make up the angle for both triangles, I have this side, which is X, over this whole side, which is 2X. These cancel out, and I'm left with a half. Not 2, a half. And then for this side, I have Y, and that's over this whole side, which is 2Y. These cancel out, and I'm left with a half. All right, now since I have this angle in common, and I have the ratio of the sides that make up that angle, they're equal, I could say the triangles are similar by SAS. All right, we did lots of examples there. If you have any questions on those, please make sure to ask. Now we're going into some problems with real-world applications. Okay, example 2. All right, separate shadows and similar triangles. Okay, with shadows, you can use similar triangles. Check this out. So parallel sun rays hit a clock tower and a stick. All right, so the sun rays are coming down at a particular angle. All right, hitting the clock tower and the stick. A student uses the measurements shown in the figure. What shortcut can be used to show that the two triangles are similar? Okay, well, you would hope that we have right angles here. So they share one angle in common. And then here's the big idea. Check this out. This is interesting because this is what mathematicians back in the day used to calculate various distances and measurements around the planet. All right, the rays of the sun, they are parallel, okay? And then I have the ground, and then these triangles that are formed, okay, I have corresponding angles here that are congruent. So I could say that the triangles are similar by AA. Okay, now what is the height of the clock tower? Okay, well, using your understanding of similar triangles now, I could say 8 over 32, since those are the corresponding sides, is equal to 12 over the height of the clock tower. All right, so there's your setup. Let's figure out the height of the clock tower. Before I move forward, I'm going to simplify this to 1/4, make life a little easier. And then h is equal to 48 feet. All right, that's the height of the clock tower. That's all there is to it. All right, next example, overlapping shadows and similar triangles. All right, painter is preparing an estimate to paint a building. To approximate the building's height, he stands so that the top of his shadow coincides, which means overlaps with that of the building. So here he has this shadow, and then here's the shadow of the building. And so he's stopping right where the shadow for his head meets the top of the building shadow. All right, now the painter uses the measurements shown in the figure. What shortcut can be used to show that the triangles are similar? Okay, well here we have right angles. It's safe to assume in this case that they're right angles because there's no other way to figure out the problem, and it's an approximation. All right, and I have this little triangle and I have this big triangle here, and they both share this angle right here in common. So the triangles are similar by AA. All right, so now that they're similar, I could apply some of the properties for similar triangles. What is the approximate height of the building? Well, I know this length here is 2. I'm going to put that over the length of the person, or the height of the person, 6. All right, so I'm using this distance, the small distance for that little triangle, over the height of the triangle. So I'm going to use the large distance going horizontal over the height of the building. You just have to be consistent. H. All right, so I'm going to simplify this to 1/3, cross multiply, and H is equal to 42 feet. Done. All right, this is an interesting problem. Mirror and similar triangles. In order to estimate the height of a tall pine tree, a student places a mirror on the ground and stands where she can see the top of the tree. So she places it in a position, and then she walks back a little bit. She looks down, and she could see the top of the tree in the mirror. Pretty cool, huh? Okay, what shortcut can be used to show that the triangles are similar? Well, you would hope that the tree grows at a right angle and that she's standing at a right angle. And then the angle at which she looks down at the mirror, all right, that line of sight, it bounces off the mirror and creates 2 congruent angles. All right, so those are the angles from the deflection. All right, so these triangles are congruent by, or not congruent, the angles are congruent, so the triangles are similar by AA. Now, what is the height of the pine tree? Okay, well, let's look at this here as a small triangle and this here as a big triangle. So I have the distance from the person's feet to the mirror, which is 3 feet, over their height. And that's equal to the distance from the tree to the mirror over the tree's height. All right, so we cross multiply, have 3h is equal to 60, divide by 3, and h is equal to 20 feet. Done. All right, one more. All right, now example 5, landmarks and similar triangles. All right, this is how you could figure out the distance across a river without having to cross it. All right, a student places 3 stakes, or in other words, wooden poles, and uses 2 trees to determine the width of a river. All right, I have 3 stakes. I got 2 trees here. The distance between stake 1 and stake 2 is 80 feet. All right, got that here. The distance between stake 1 and stake 3 is 120 feet. Got that. The distance between the trees is 160 feet. Okay, got that. All right, what shortcut can be used to show that the triangles are similar? Okay, check it out. We have this small triangle here, and then I have this big triangle here. Okay, and they share this angle in common. All right, and the idea is that these are right angles here. All right, you set everything up, or you approximate it to be that way. So the triangles are similar by AA. And now what is the width of the river? Well, we'll call this distance x, right, from here to here. Okay, so I have the small blue triangle. I know that this distance is 120. I'm going to put it over the other distance from the triangle, which is 80. Once again, there's many different ways to set up the ratios. Just be consistent. Now I'm going to take this whole side to the green triangle. It's not 120. It's not x. It's 120 plus x. All right, watch out for that. And then over this horizontal distance for the big triangle, which is 160. Okay, so now I will simplify this fraction before I cross multiply, which is 3 over 2. I cross multiply, and I get 180 is equal to 240 plus 2x. Oh wait, that's not 180, that's 480. There we go. Okay, so I have 240 that I'm subtracting, and I get 240 is equal to 2x. So I divide by 2, and x is equal to 120. All right, so that's the width of the river, 120 feet. All right, I use very simple numbers just so you're able to grasp the idea. The setup is the most important part. All right, if you're able to set it up properly, then it doesn't matter what numbers you work with, you'll be able to solve it correctly. If you have any questions, please make sure to ask for help. Begin the assignment.